Yes, I'm
You
able to
you
see the screen.
Okay. So, if when we say data science or artificial intelligence or machine learning or deep learning, how clear you are between all of them, or what exactly each one of them do? Do you have any clarity, or rather, if you say what is data science, you have your own baked definition for it.
Yeah, data science is when you deal with data to find insights and or find patterns and assume something, right? When a new test set comes, you can assume it based on the previous learning.
Uh-huh, uh-huh, uh-huh.
So this thing is called AI is all total a big set in that machine learning is a part of AI.
Okay. Yes. Yes.
And
So what we will do is
hmm,
whatever we said.
hmm. Hello, 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 hello. 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 Hello.
Shiva, you're able to hear me?
Yeah. Yeah.
Okay.
Okay.
So when we say artificial intelligence,
Hmm.
forget artificial component. What is intelligence?
Intelligence is determining something means it's your IQ.
Okay. Again, IQ is intelligent quotient. So what is intelligent? Then we will define what is intelligent quotient.
Intelligence is uh, is your what how much to how much extent your brain can think.
Mm, okay. So do you want to refine it? Yes, you're there almost.
It's how much extent your brain can think and react over a situation or a given condition.
Okay. Which indirectly says what is your decision making capabilities which are
Hmm.
appropriate for a given situation.
Hmm.
Right. So the moment we connected on this GoToMeeting or a Zoom,
Hmm.
so we greeted each other. Right. So which means in reality we knew basically it was a session. We have to introduce each of us so that we get to get the background and get connected for our session.
Right.
But imagine if we have this session and one other mentally retarded person joining in.
Hmm.
So he also will have decision, but the decision will not be in sync with what's happening.
Right.
Probably if you have a classroom, if you
Hmm.
have a specially retarded or mentally retarded person, the
Hmm.
moment he comes, he might start jumping, he might
Hmm.
start rolling,
Hmm.
he might start laughing. The reason is his decision capabilities are not in sync for a given situation. He is
Right.
also making decisions because he's doing an action, there is a decision,
Right.
but that decision is not in sync with the given requirement.
Okay.
So just defining intelligence in our own words is any action which is amicable for a given situation
Hmm.
from the data what we have gathered
Hmm.
is intelligence.
Hmm.
Now you would have seen all this new age cameras, right?
Right.
The
Hmm.
smartphones which claims having AI mobile phones,
Hmm.
or sorry, AI cameras, right?
Hmm.
Artificial intelligent cameras.
Hmm.
What is the intent of a camera?
The intent is to detect the features which are present in those pictures.
No. We'll step one step back. In intent of a camera, why do we use a camera?
To capture an image.
So to capture an image. So the only difference is we try to take a perfect image or a perfect photo,
Hmm. We're
right?
gathering more information.
To gather more information,
Right.
we try to use this tool called as camera so
Hmm.
that it can be
Hmm.
repeatable and replicable,
Right.
and whatever we call, whatever the photo we take, we always try to make it as a perfect photo. So
Right.
each one of us might use different means. I may take 10 photos so that I can say that okay, at least one of the photo might be a perfect photo within the given data set of 10 photos.
Hmm.
Or you, for example, when you are shooting a photo,
Hmm.
you might adjust various parameters like adjusting the light, adjusting the zoom, adjusting the megapixel, adjusting the aperture. So you technically can adjust various parameters, 5 or 6 or 10 parameters, before you convince yourself to decide that whatever I am seeing is a perfect image to be clicked on, which means you
Right.
are taking 5 to 7 or 10 decisions before a photo is clicked,
Hmm.
right?
Right.
This action involves a fine tuning or finding a decision within the data set, in sense how much light is appropriate for a given condition, how much zoom is appropriate for a given condition, where
Hmm.
exactly you should shoot it, which camera you should use it. All these are decisions which are happening, which are enabling you to take that perfect photo.
Hmm.
But if you can make a machine to take this decisions on your behalf, in sense the moment you point at something, then there are algorithms which will kick in to adjust the light, adjust the zoom, adjust the aperture,
Okay.
adjust the megapixel, to make sure the photo what you have taken is a perfect picture,
Hmm.
which means you are artificially inducing the photo taking capabilities in that particular machine.
Hmm.
Means previously whatever you were manually deciding, now
Hmm.
an algorithm is deciding for you.
Right.
But as a human you can do much more beyond it. So right after taking a photo you can sip your coffee,
Hmm.
while a camera which is artificially enabled for photo capturing can do only that, in sense it has a purview where it can do its action to take a perfect picture, and to take this perfect picture whatever the decisions are needed can only be done,
Hmm.
right? So
Hmm.
this quotient of seeding in decision making on a machine to take an appropriate action is artificial intelligence.
Hmm.
Now we will see what is science. What is science?
Science is a technology uh, for improvement of human behavior. Means uh, it is a study of what is happening. Means
Okay.
hmm.
Is there a way you can refine it?
Science is study or research of what is happening in present.
Mm, okay. If I say 2 plus 2 is equal to 4,
Hmm.
do you think is it science or it's not science?
It's it's stats. It's not science.
It is arithmetics, but there is a logic,
Right? Yes, there is a logic.
which means anything which is replicable, repeatable, logical, scientific in nature is science. In sense, 2 plus 2 is equal to 4 for anybody in India, for anybody in Pacific Ocean, anybody in Atlantic Ocean, which means it is repeatable, it is replicable, and it is logical.
Hmm.
For example, if I show you a photo of Mona Lisa,
Hmm.
and if I ask you to write 4 parameters about it, and I write 4 parameters about that photo, what is
Hmm.
the permutation that the 4 parameters either one of us write have any common thing? What is the probability of our parameters matching? It
Hmm.
is anywhere between 0 to 100%, right? There can be any
Right.
parameters which can be same,
Hmm.
or there may not be any parameter, even a single parameter may not
That I
match,
mentioned. Hmm.
right? So you might start thinking about who is Mona Lisa if you don't know. If you know Mona Lisa, you might start thinking why we are talking about Mona Lisa in a data science class.
Hmm.
Or if you are saying, okay, where exactly is Mona Lisa? Why exactly it has become so famous? So
Hmm.
it is because the question was so open-ended. Our mind did take an approach which we felt logical, and we put 4 facts about it.
Right.
Similarly, I would have done 4 facts about it. I would have written something about the size, the price, the location, the painter who painted it, whatever,
Hmm.
which is the artistic approach for a given object.
Right.
Right? The logic which I used for writing my four parameters
Hmm.
was over and above science, so it became arts.
Right.
Which means the replicability, repeatability quotient for that were very, very, very minimal.
Hmm.
Okay, so whatever is replicable, repeatable is scientific and logical. The thing which lies above science is your artistic view or arts, because there is a creativity quotient.
Hmm.
How you feed your data cells to take that particular decision. That's why even in the real time world, arts or artistic approach is more complex than the scientific approach.
Hmm.
Then over and above this is your emotional quotient. In sense, your decision making skills for your artistic approach changes with emotions. Which means when you are hungry, the decision what you make versus when you are angry, the decision is different.
Right.
Right? So what I'm trying to say is, all in the entire space, we have just scratched the surface to decode or unbox something which is scientific alone for now. We are not even going beyond scientific and trying to see, can a machine draw a painting which is artistic in nature? We are not there. We are first trying to say, I'm showing you a picture, how easily you can replicate it.
Hmm.
If you can replicate it, I can repeat it in 10 places, which means today a doctor is science by nature. In sense, for any person who gets fever anywhere in India or anywhere in the world, the first thing he will have to be prescribed is paracetamol, which is repeatable, replicable. There is a logic behind it. Why do doctors prescribe paracetamol for fever? Right?
Right.
So the same thing, if you ask an artist why he painted something, it is his creativity which has landed in there. The logic which he can come is not something which can be easily repeatable or replicable.
Hmm.
Okay, so
Okay.
as part of data science,
Hmm.
or basically anything which is repeatable, replicable on a given data set,
Hmm.
data science.
Hmm.
Now, saying this, I will give a small example how these patterns which are available, because what happened is in last 3 decades after 1990s, the world started adapting information technology using computers. Before that, the adoption rate for computers were very minimal, right? In 80s and 70s, you had hardly computers in the world. It was more for not for general public consumption, it was more for research or defense or something like that.
Hmm.
So why this was important is, since that point of time the organized data was very minimal, you had very limited scope to find patterns in the given data sets.
Hmm.
While late 90s, late 2000, the organized data today, for example, if you have switched on your Google location services,
Hmm.
Google knows where you are, what
Right.
time you left your home, what time you reached your office, what is the path you have taken. All these things is getting organized, capturing.
Hmm.
So once Google collects this for 30 days or 45 days, it
Hmm.
can predict your pattern. It can say, okay, you wake up at 7, you go to office at 7:30, you are leaving your office by 6 o'clock. So
Hmm.
whatever, the pattern can be anything. So it can patternize from a given data set.
Hmm.
So this art of finding patterns in a given data, which is replicable, repeatable, is data science.
Right.
Now, I will give a simple example. You know Walmart, right?
Yes.
So, Walmart did a simple data science experiment.
Hmm.
I will first say what they found out, then we will see how difficult it would have been to find that if it was not through a machine or not applying any of the data science algorithm.
Okay.
So, they did an simple data science, or rather they did a data science experiment, not a simple one, to understand what gets sold together.
Hmm.
Okay, so the inference or the output of this data science experiment was, what they found is the diapers and
There.
beer cans
Hmm.
over the weekends were getting together.
Hmm.
You know this example?
Yes, I have heard this.
Sorry, you okay? So if you have seen this, the diapers, which is the kids section, while the beers, which is the adult section,
Hmm.
it was really amazing for human brain to think that something which are so diversified in nature can be sold together.
Hmm.
Right? The reasons can be anything. The reasons can be anything. It can be something that more men are going to buy, or women are buying, or predominantly it's an family affair to buy, whatever. But what was happening was, this was happening in sense diapers getting sold with
Hmm.
beer cans. And when they try to test this by co-locating diapers and beers together, they see a organic growth of sales, which means previously also Walmart had diapers, Walmart had beer cans, but when they figured this out, they figured this pattern and they co-located. You know a Walmart, right? It is almost a half a kilometer store, and the
Hmm.
kids section and the beer section usually are far off.
Hmm.
The moment they co-located this, the sales of same beers and diapers
Increase.
organically grew.
Right.
Yes, they increased. Now, if you have to see the data set, there are more than 500 Walmarts in the US.
Yes.
And if you have to take weekends, 3 days of the week is considered weekends: Friday, Saturday, Sunday.
Hmm.
And if you have to see 4 weeks in a month,
Hmm.
on an average, any person who walks into Walmart buys anywhere between 22 to 25 items.
Hmm.
That is the average list of items what a person buys in Walmart on a weekend.
Hmm.
Then there are roughly around 1200 to 1400 people who visit Walmart every weekend day.
Okay.
And if you have to see, you will have to take the data set at least for 12 months before you can do any experiments of this nature.
Hmm.
So if you multiply all this, the data quantity might run into few millions, right? 500 Walmarts, 3 days a week,
Yeah,
4
it
weeks
will
a
be in
month,
millions.
some millions.
Hmm.
In this millions, there is a permutation combination of all possible things. There can be so many people who have not bought either a diaper or a beer.
Hmm.
And to start with, you did not know what are the ones which are getting sold.
Hmm.
Because now that we know the output, we our brain can start picking up, saying that wherever there are beers, can we see whether there are diapers, or wherever there are diapers, there are beers. We can do it now. But when you first started, you did not have a destination.
Hmm.
Right? You did not, the intent was to find which are getting sold together.
Hmm.
So that thing could have been because as humans, it is very difficult for us even to assume how can these two diversified categories be sold together. But with identification of patterns, it was concluded that these are the things. And the way it got proved is by drawing that and trying to organically co-locate them within a store to see whether the data science experiment what was done was really working or not.
Hmm.
Right?
Right.
Saying this, then what is learning?
Learning is understanding or inhaling something from a situation.
Learning is inhaling something, or what is the other one you said?
Understanding something from a given situation.
Understanding something from a given situation. Okay. So then, what is training?
Training is uh, training is when you understand it and when you store it in a place. That time we will say training.
Mm, you want to refine it? Think through it. What is
Learn.
learning and training?
Learning is mm, learning is thinking something suppose we have a data and we are after finding insights we understand that there is what relations between the variables that are learning.
Right. So you are all, you are just nailed the coffin, right? So the art of converting data into knowledge
Okay.
is learning. In
Okay.
sense, when you are walking on the road, you are just collecting data. But when you have to take a decision, you apply the collected data as a knowledge to make a decision. Right? Next time when you are crossing your road, just think through it, right? You have collected the data saying that which vehicles are coming in what direction, how are people walking in, what is the crisscross functionality which is happening, and on the go, you decide at what point of time you have to cross the road.
Right.
which means the data collected using your understanding, which got converted into knowledge by asking so many questions internally, so that this data has become a knowledge and you execute a decision. Which means the art of asking many questions on the collected data set so that it can get converted into knowledge
Right.
is learning. So if you have 100 people in a classroom, for example, it could have been in your school or college classrooms, you have 50, 100 people, 100 students, but each of them understanding the topic what is being discussed is very different.
Hmm.
The reason is their learning quotient for the sound which is getting created in that room is very different. For example, now I am talking, which means I am creating sounds.
Right.
You are listening to the sounds, but what you understand versus what I want you to understand, there will be a gap.
Hmm.
Because whatever you are questioning yourself, those things will get recorded as knowledge data sets.
Hmm.
Whatever you are just listening without questioning are recorded as only simple data sets.
Hmm.
Which means the more questioning you do within yourself, the more knowledge quotient for this sounds are happening.
Hmm.
Then what is training? If you say learning is the art of converting your data into knowledge, then what is training?
Training is just training is when we converted the data into knowledge for future reference, we can use it.
So, if I have to pick this example, how did you learn your cycling or swimming?
After getting training.
Which means the first day when you started cycling, it was the art of learning, which means you had so many parameters for you to handle. While once you learned that art of balancing, which is the core component, then you fine-tuned it, which means you started cycling speeder. You started, if you wanted to do some challenges of cycling without having your handle, holding your handle, or cycling with a single pedal, which is the art of perfection for the given data set is your training. Right? So if I pick this one other example, today, if I ask you to cook a Turkish dish, first you have a resistance from your brain. What is this? I don't know anything in Turkish menu. I'm being asked to cook Turkish dish, which is the first block. Then I say, I will sweeten up the process by giving you all the ingredients, the recipe, the approach, and a YouTube video to cook that Turkish dish. Then probably you will take 1 hour or 1.5 hours on the day one, because there is an activity involved in learning this. You will have to see the YouTube video, coordinately see what are the ingredients which have to come in sequence, whether all the ingredients are available. Then you do it within 1.5 hours or 2 hours, whatever the time span. But if you repeat this cooking, the same dish for next 10 days or 15 days or 30 days, the 30th day, without any of the help, you will be able to cook in 1/10 of the time. Probably in 10 minutes or 5 minutes, you cook it, because you got trained in doing this, and you have your decision making skills to say that what comes before, what comes next, and you will also fine tune the process of saying how to make it more optimal. What took like 2 hours the first day can take only 10 minutes the 30th day. Right? So that art of perfection on the given data set which got converted into knowledge is training. when you first join any company, you are said that you are trained. You are not saying that you will do a learning, right?
Hmm.
The reason you will be said that you will be trained is because the ground laying understanding is you have the knowledge which the companies can fine tune before they get perfectionists.
Okay.
This art of converting data into knowledge is learning, and the art of converting that learning into more precise activity is training.
Hmm.
But how do you we said which is scientific, which is logical, which is repeatable, replicable data conversion? To do all of this, you need something which can help you to build, that is your program,
Programming skills.
right? So
Right.
which is whenever you are writing a program and executing, is it not replicable, is it not repeatable, is it not logical?
Hmm.
Yes. So doing all these things,
Hmm.
one second, give me a second. So doing all of this
Hmm.
is enabled by a programming. The programming can be anything,
Hmm.
right? It can be Java, Python, R, anything.
Yes.
So if you see this, the way each one of them build each over and above, programming facilitates learning, which facilitates pattern identification, which facilitates decision making, is how your artificial intelligence or your AI is correlated.
Okay.
Okay.
Hmm.
So what is this?
This is Audi's.
Symbol.
Yeah.
Then why is odd symbol here? The reason
Maybe you
is,
want to define some sets and subsets of something, intersection and all.
right. So the way to have a rough reference for all our four acronyms: the artificial intelligence, the machine learning, the data science, the programming, is like your ODI symbol,
Okay.
which means the programming overlaps with your machine learning, the machine learning overlaps with your data science.
And it
All
overlaps
these
with
three
AI.
overlapping to get an application which is intelligence, which is self-decision making, is your AI.
Okay.
Right? So you can have any programming concepts to make your learning, to find some pattern on the collected data, to come up with some inference.
Okay.
Is the way which we can define your artificial. So whatever 15-20 minutes or half an hour back where we started versus where we are, do we have a better clarity on all this
Yes.
acronyms? Or
Yes.
because these are your crux, where all your verticals stand upon it. You will do deep learning, which is part of your machine learning or an extended machine learning, or programming or pattern finding. But at the end, the building blocks, these are the four pillars. Three pillars which is supporting the roof, which is your artificial intelligence. Right?
Right.
So any questions?
No, understood.
Then
Okay.
we did speak about learning.
Yes.
Right? So in our own definition, we said anything which is conversion of data into knowledge is
learning.
Then this learning, if it has to be seeded into a machine so that it can take decision, is machine learning.
Machine learning, right?
Right? In that example of camera, what we spoke, the machine which is the camera is getting some decisions to adjust the light or the
Zoom.
aperture or the zoom
Hmm.
is a learning quotient. So next
Right.
time, the moment it sees some light which is more or less the same, it automatically readjusts your zoom and readjusts your pixel accordingly,
Hmm.
right?
Right.
So any machine learning is an act of some kind of decision making.
Hmm.
Do we agree?
Right.
So the moment we said that it is some kind of decision making, we will have some categories, because each of the time when we make decisions also, there are so many influencers, so many parameters, so many variables which make a decision the way it is taken. So for example, when it is too cold, you feel you will have to have something which is really hot. It might be a cup of coffee or a cup of tea, which means the environment is influencing somebody to decide what should be the next action.
Hmm.
Right? But
Right.
what kind of environment, how is the different types. So at a very, very high level, which I know you are working day in, day out, but at a very, very high level, the learning quotient can be categorized into three different things.
Right. Supervised, unsupervised, and reinforcement.
Right. Then, what is supervised learning?
Supervised learning is in a given data when we have labels. That time, and we know the business purpose. We know the business objective. At that time, it is known as supervised learning. When we have, when we know what are our, when in the training that I said, when we know what are our inputs, that time, and we have defined outputs for it. That time we say that it is supervised.
Right. Now, whatever you said, absolutely correct. If you say, for example, you go to a grocery store, you see set of vegetables or set of fruits.
Right.
The moment you see, if you are able to get grounded to an exact name of a fruit with the variant, with a help of an aid, the aid can be underlying name below it, or somebody shouting for it, or calling out for it, then you are getting an external help in making your decision, which is supervised learning. So for example, if you are going to a local market, somebody is calling tomato, tomato, or onion, onion, and he is referring to something, he is giving you that labeling. He is saying this particular fruit or a vegetable is called onion and I am here for sale. Which means the labeled information is being provided to you in terms of in whatever style and fashion, which is helping you to correlate and say this is an onion or this is an apple. Right? So if you see this example, you have a set of apples, which is your raw data. There is a supervisor who helps you to train a given data set to give an output. This action, which is capsulated in an algorithm, to process it before it can be called out saying it's an apple. Which means this supervisor is influencing your decision.
Okay.
Is called as supervised learning. There can be various fashions and styles in which the supervision can happen. It can be audio, it can be video, it can be visual. So anything which is labeled, which can influence your decision to conclude something, is your supervised learning. Right? So similarly, if you see this example, there are various kinds of creatures or animals. Within supervised learning, what you try to identify is which exactly is a duck. There are only two things, is whether it's a duck or not a duck is the thing, right? But if you say the first one is a duck, duck, not a duck, duck, not a duck, not a duck, is basically you are trying to find an influencer or a labeling to see whether it is a duck or not. You might see at some parameters, visual aspects, somebody talking on it, whatever is it, that influences your decision to make a learning so that you can reuse this particular thing. Right? So this act of doing things is supervised. One other very good example is a small child learning walking. Right? The first time he tries to walk, he falls. Which means the balancing activity for the kid is very minimal, while a parent supports or labels it by helping him to give the directions to see how he can attain the act of balancing. That's what we do in walking, right? Walking is one of the most complex activity any mammal can do. You can only have a handful of mammals which can walk with 2 legs, right? Many of the mammals walk with 4. When human can walk with 2, it is all about the art of balancing, which means how you can balance is what you can decide. All right. So this act of making a decision with an influence of a label is your supervised learning. Some of the key algorithms, there are various algorithms, key algorithms for your supervised is your regression, random forest, SVMs. We will talk on that, but just wanted to scratch on that. You have some of the use cases for supervised learning?
Supervised learning use cases like determining weight according to heights.
Right.
Then housing price determination, temperature determination, what will be temperature tomorrow based on previous data. Okay. This fingerprint also which you are showing based on the previous images stored, it compares.
So the first example is your Go Google or Cortina or Siri, right? Whatever you have in your Windows, it is called as Cortina, while in iPhone it's on Siri, or in your Android it is a Go Google, right? So that is a supervised learning. The reason is for your accent, for your questioning, for your reasoning, there is an output.
Right.
Similarly, if you see your fingerprint unlocking, the first time when you have to set up your fingerprints, it will try to take a lot of data sets which it can compare to see whether it is logical or illogical before it can unlock the device. If you see the weather, for example, if I say, Shama, what will be the temperature on May 15th in Delhi? You will still be able to say, because you identify May is the end of your summer, Delhi being a tropical state or a city. With the data what you have, you probably say it should be around 38 to 39 degrees. Which means even though it is a month and a half or 2 months from now, you with your supervised data content, you are able to give an output saying what should be the temperature or predicted temperature. So this kind of predictive which can happen based on the data set under a supervision is your supervised learning.
Okay.
If you have to see some examples in a banking, predicting the credit worthiness of the customer. So you work in any tech park, which city you work in India? Bangalore, Delhi, Bombay?
Bangalore.
Bangalore. Okay.